Welcome to Nature Calls, Conversations from the Hudson Valley. Our team's goal is to present science-based information about gardening and all things nature in New York's Hudson Valley. Hosts Jean and Tim, along with team members Teresa and Linda, are Master Gardener volunteers for New York's Columbia and Greene counties. So if you're interested in gardening or nature, or nuggets of information about what's happening outside your door, settle in. Enjoy the conversation. Whatever the season, we have something to say.
Welcome to Nature Calls, Conversations from the Hudson Valley. I'm Tim Kennelty.
And I'm Jean Thomas.
We're doing something really exciting today. We're starting something new. It's our retrospective. Now that we have this broad catalog of content with multiple segments on different topics, we're going to start a retrospective. We're going to put some of those segments that have like topics together in individual episodes.
So if you want to listen to a particular segment that's caught your attention, you don't have to shop around between different episodes. You'll find them clustered together for you so you can listen to 3 or 4.
So today's episode is a compilation of segments on beekeeping.
So listen in for the hum of the hive. Welcome to the Hum of the Hive, a monthly segment of Nature Calls, Conversations from the Hudson Valley that explores our natural world from the perspective of the honeybee, Apis mellifera. Hello, I'm your host Linda Aydlett, and I'm a Master Gardener volunteer with Cornell Cooperative Extension of Columbia and Greene counties. I'm also a Cornell University Master Beekeeper who's been keeping bees for over a decade now. Like many beekeepers I know who've been bitten by the bug, I've become quite enamored with honeybees, and I'm always learning something fascinating and new about these remarkable creatures. So come with me as we embark on a journey with the honeybee, following her through the 4 seasons, starting with, well, right now. We're in the midst of winter. The weather's frigid and there's not a bloom in sight. Honeybees are one of the few species of bees that form colonies able to survive year after year. Hopefully these colonies are now ensconced in a warm, dry cavity that could either be the hollow of a tree or inside a man-made hive. And if the prior seasons were bountiful, there's plenty of honey stored away to hold them until the nectar-rich blossoms are once again plentiful in spring. Even though they're not out foraging, they're working hard within the hive, keeping each other fed and quite toasty warm 24/7, even during blizzard conditions outside the hive. But until spring comes, how do the honeybees survive winter? Well, let's take a look inside. As cold-blooded creatures that don't hibernate, honeybees have developed several means to help the colony survive in cold climates. Starting when temperatures drop to the lower and mid-50s, individual members of the colony gather to form a huddle about the size of a soccer ball. This is what beekeepers call the winter cluster. As temperatures drop even further, the winter cluster tightens and becomes even more compact. At the same time, the honeybees on the outer edges of the cluster are packing as tightly together as they can against each other to form a shell that basically encases the cluster, much like the mantle encases the core of our Earth. This mantle forms an insulating shell an inch or 2 thick so that the heat is kept inside the cluster and helps preserve precious energy. With an insulating mantle in place, the cluster simply doesn't need to heat unoccupied space within the hive box. Using thermal image cameras, researchers discovered that individual bees, called heater bees for the task they're performing at the time, can provide enough warmth to keep the nest at precisely the right temperature in spaces immediately around themselves. Heater bees use an anatomical feature all bees have in a surprising way that allows the cluster to keep even warmer. And it's on their wings, believe it or not. Honeybees can't fly at temperatures much below the mid-50s. It's just too cold for them to move their flight muscles. So in winter, they're stuck inside the cluster. While it is indeed much warmer, there's simply no room to fly. Using a ridge of hooks called hamuli, each individual honeybee is able to temporarily unhinge and detach all 4 of her wings from her body so that she can use her flight muscles in a vibrating or shivering movement. So instead of taking off in flight, she's literally shivering in place. This shivering raises the body temperature of each honeybee, and collectively, they produce the right amount of heat needed to keep the queen toasty warm. Somewhere in the mid-80s. Yes, that's 80 Fahrenheit, even when the wind's howling and the snow's piling up outside. And if the comb at the center of the winter cluster contains brood, that is, eggs, larvae, and pupa, which helps the cluster increase the temperature to an even hotter, tropical like 95 degrees or so, needed for the brood to develop into adults. While the center of the winter cluster is being kept toasty warm, quite the opposite is true for the honeybees on the outer mantle layer, who are continually being exposed to the bitter cold. To survive, they enter into a state called torpor, which means that their metabolism slows down so much they appear quite motionless, if not dead. If left in this state, they could indeed freeze to death. To prevent this from happening, honeybees on the outer rim are slowly rotated toward the center of the cluster, exchanging places with their warmer sisters. It's remarkable that at no time is anyone bee in charge, not even the queen. Each individual works in concert with the others for the common good, which, at this moment, is to preserve the colony through the severest season of the year, winter. Cooperation, communication, and resiliency are traits we'll see repeated throughout the seasons. So join me for the next episode of The Hum of the Hive as we delve further into the fascinating world of the honeybee. Thanks for listening.
You're listening to Nature Calls, Conversations from the Hudson Valley.
Welcome back to The Hum of the Hive, a recurring segment of Nature Calls, Conversations from the Hudson Valley. I'm your host, Linda Aydlett, a Master Gardener volunteer with Cornell Cooperative Extension of Columbia and Greene Counties, and a Cornell University Master Beekeeper. Over the next couple episodes, we'll talk a bit about the roles within the social structure of the colony, where each honeybee has a place and a job to do, almost like a cog in a well-oiled machine. But not cogs in an impersonal or Borg-like way, as fans of Star Trek The Next Generation might envision, more in a manner that evokes wonder and amazement when you look more closely at how honeybees have adapted and evolved to survive. Most of you probably know that there are 3 distinct groups or castes that make up the social structure of a honeybee colony. That is the queen, the worker, and the drone. The colony usually has only one queen, although at times a mother and daughter may be roaming about the combs, but only for a short time, maybe a season or so. There can be literally tens of thousands of worker bees at one time, each and every one focused on a specific job to do. Drones or male honeybees make up the third caste and are present in much smaller numbers, in the hundreds, perhaps 1,000 or so in the height of summer. Each caste, queen, worker, and drone, has their own special niche to fill, and none can survive long without the others. So let's start with the queen bee, as she's often thought of as being the leader of the colony. She is the largest of the honeybees. Of the tens of thousands of females in the colony, the queen honeybee is the only reproductive female, which makes it critical that she stay healthy and alive for the colony to thrive. And what makes a queen bee a honeybee? Well, from the moment she emerges as a larva from an egg, she'll be fed a special substance called royal jelly for her entire life. It's called royal jelly because its primary use is to nurture the queen. Royal jelly is incredibly nutritious, containing twice as much protein and 3 times as much fat than is typically brought in from either pollen or nectar collected from plants. A queen bee is quite limited in what she can do. She can't groom or feed herself, so she is often followed by a retinue of worker bees that surround her to take on those tasks for her. Her task is to perpetuate the colony, and she does this by laying up to 2,000 eggs per day, mainly during spring into summer. That could add up to be about 1 million eggs or more laid over her lifetime. Day in and day out, the queen is continually traveling over the comb, searching for empty cells that have been cleaned and polished just for her. Researchers have found that as worker bees are building comb, they construct 2 sizes of hexagonal cells that are just a couple millimeters difference in diameter. There's an interesting reason for this. As the queen comes upon a suitable cell, she'll carefully measure the diameter with her front legs. She'll then back up into the cell and drop her long abdomen down until it touches the bottom, where she'll deposit a single egg that looks like a grain of rice but is about half its size. So why did she stop to measure the diameter? Believe it or not, the cell diameter tells her whether to fertilize the egg or not, and whether an egg is fertilized or not determines the sex of the adult bee that will emerge a few weeks later. If the cell was measured to be the smaller diameter, the queen would leave an unfertilized egg, which would develop into a female worker bee. But if she comes across the slightly larger cell, she would lay a fertilized egg, as this cell's diameter would better accommodate the bulky girth of the drone or male honeybee. What's fascinating is the queen doesn't decide the distribution of sexes within the colony. The worker bees who built the comb did. And how do the worker bees decide how to distribute the sexes? Well, that's something we'll talk about in the next episode when we explore the broad range of roles each worker bee plays in her short lifetime. So back to the queen bee. 3 days after every egg is laid, regardless of whether it's been fertilized or not, a very, very small grub-like larva emerges and is fed royal jelly for the next 3 days. Keeping in mind that the queen is laying hundreds if not thousands of eggs per day, that's hundreds if not thousands of hungry larval mouths that are being fed royal jelly. And it's done for a very specific reason that once again helps ensure that the colony lives on. But what happens if the queen dies? Say, for instance, she's accidentally squished by the beekeeper. Sadly, it happens. The colony would have to scramble to raise a new queen, which they can do without missing a beat. Remember, a queen is fed royal jelly her entire life, so that by having this emergency reserve of potential candidates, nurse bees will single out maybe a dozen or so of these newly hatched larvae and continue feeding them nutrient-rich royal jelly needed to develop into queens. You may have heard that there can only be one queen bee per colony, and for the most part that is the case. So what happens in this scenario when dozens of queens in the emergency reserve hatch out within hours, if not minutes, apart from each other? In short, these new queens will seek out and try to sting their rivals to death. It's basically survival of the last queen standing. Emerging queens will often emit a piping or tooting sound. Let's take a listen. Did you notice a second queen piping in response? Often as not, a rival will pipe back. If the rival piping in response hasn't emerged from her casing yet, she's doomed, as she'll be hunted down and stung to death through the casing. A queen stinger is not barbed, so she can inflict multiple stings with no damage to herself. Once her rival is dispatched, the surviving queen is off to hunt down the rest of her rivals. It's basically a battle royale, where not only the victorious new queen survives, the colony lives on as well. This whole process is a colony's way of having a backup plan for replacement queens should the current queen be superseded, accidentally killed, or take off on a flight with a swarm. As Dr. Jamie Ellis, a highly respected entomologist at the University of Florida, said in a recent webinar, "You can't make this stuff up." We always think of the queen bee as being the one who's in control, but as we see, it's not always the case. She can't feed herself, she can't groom herself, she can't even decide whether to fertilize an egg or not. Even so, her role as the only fertile egg layer in the colony is crucial, and she works in concert with others in the colony, which at this time of year is to grow a strong population that's ready to take flight in time to harvest the nectar bonanza that will be available in just a month or two. So join me for the next episode of The Hum of the Hive as we delve further into the fascinating world of the honeybee. Thanks again for listening.
You're listening to Nature Calls, Conversations from the Hudson Valley.
Welcome back to Hum of the Hive, a recurring segment of Nature Calls that follows the honeybee through the 4 seasons. I'm your host, Linda Aydlett, a Master Gardener volunteer with Cornell Cooperative Extension of Columbia and Greene Counties, and a Cornell University Master Beekeeper. In this episode, we'll talk a bit about the roles of the worker caste, whose population within the colony can range anywhere from 30 to 90,000 bees, depending on the time of the year. Each and every worker has a specialized role, mostly based on approximate age, as well as the needs of the colony. While the other 2 castes, the queen and the drone, are focused on reproduction, worker bees pretty much do as their name implies. They get all the rest of the work done that's needed to support the colony. The lifespan of a worker bee is actually quite short, typically 6 to 8 weeks during honey production season, which is spring into summer. Her lifespan can be divided into 3 general phases. The first, she's developing from an egg to a larva to pupa to adult. In the next phase, she's living pretty much entirely inside the hive as a house bee, caring for brood, processing food, and maintaining the nest. And for the final third of our worker bee's life, she's venturing outside as a field bee, gathering critical resources for the colony. In this episode, we'll take a closer look at the middle phase and follow her as she transitions from a young house bee to a field bee. As a newly emerged house bee, the first thing she does is literally clean up her room. She turns right around, pulls out the cocoon casing from her incubation cell. It's no longer needed. Then she cleans and polishes the cell for the queen to lay another egg. She'll hone her skills cleaning and polishing surrounding cells for a few days, then graduate to other young bee roles depending on the needs of the colony. For instance, as a nurse bee, she'll tend to uncap larvae. Uncapped larva is a stage that all bees go through from about 3 to 8 days in their development, regardless of caste. Our young worker will be found checking in on these larvae, oftentimes up to 1,000 times a day, to ensure they have enough food. When they do need feeding, the young nurse bees produce the food herself. She uses a special gland in her head that converts nutritious fats and proteins from the pollen she's consumed into bee bread, which is fed to the worker brood, and boiled jelly, which is fed to the queen and worker larva up to 3 days old in case the colony needs a new queen. When our young worker bee is about a week old, she may move into the role of an attendant, feeding and grooming the queen. As she uses her body parts to feed and groom the queen, the young attendant is also helping to keep the colony cohesive by unintentionally picking up and spreading a special pheromone the queen emits as she moves through the hive as part of the queen's retinue. This pheromone is called the queen mandibular pheromone, or QMP, and it's unique to each queen. It's also a critical substance the colony depends upon to signal to each and every bee in the hive that they still have a viable queen. This unique odor signal can fade in as little as 15 minutes from when the queen is no longer present. For instance, if she should die, is killed, or leaves in a swarm. After a couple of weeks, our young worker bee is ready to take on a variety of roles to help with processing food, which is stored in the hexagonal cells of wax that make up the comb structure within the nest. One of the most amazing feats of a worker bee at this age is the ability to literally manufacture beeswax. Using glands underneath her abdomen that convert sugar from the honey she's eaten, she extrudes wax to produce a thin, tiny flake that looks very much like a fish scale. A single young wax maker can only produce 8 of these tiny flakes each day. It's estimated it takes about 500,000 or more, that's 500,000, to produce a pound of wax. If she's not exuding wax, our young worker is building new comb or repairing old cells and helping to store food resources brought in by field bees. Food for honeybees consists of nectar and pollen. Nectar provides carbohydrates for adults. Pollen provides protein for brood. However, both nectar and pollen must be processed so they don't spoil over long periods of storage. For instance, over winter, when no forage is available to the colony. When pollen is brought in by a field bee, the field bee depends on waiting house bees to meet her so they can pull the pollen packets off her legs, freeing her to fly right back out to continue foraging. The young house bee deposits the pollen into a cell, then rams it with her head to pack it down so that there's room for more pollen to be stored in the same cell. As she does this, she mixes in a small amount of honey to help prevent spoilage from bacteria over time. As for nectar, it's mostly water and can spoil with mold over time. Our young workers remedy this by fanning the open cells of nectar with their wings, evaporating off huge amounts of moisture until the resulting substance is a thick, gooey substance we recognize as honey. Beekeepers call this ripening the honey. When about 82% or more of the moisture is evaporated, the cell's capped with a thin layer of wax that keeps debris out and prevents absorption of moisture from the air. As long as the honey is capped, it can last pretty much forever. Our worker bee is now several weeks old, quickly transitioning from a house to a field bee by taking on tasks that move her closer to the entrance. For instance, fanning for ventilation on a hot summer day, or accepting or offloading nectar from an incoming forager in a process called trophallaxis, which saves the forager from having to crawl throughout the comb to find an open cell to deposit her load. The next couple of roles we'll talk about actually start taking our young worker bee outside the hive, but only briefly. Keep in mind that worker bees have short lifespans. bees are dying all the time, both out in the field and inside the hive. Mortuary bees do literally what the name implies. They pull out their dead sisters and fly off a short distance. Then they drop the body and fly back inside to remove another that has died. And the final role we'll mention in this segment are the guard bees, sitting at the entrance on high alert, wings folded back like little fighter jets, ready to take off at an instant to meet whatever threat that they feel they need to defend against. The threat could be honeybees from another colony trying to steal their food stores, or it could be wasps and yellow jackets trying to steal their brood for protein. It could also be hairy mammals like bears and skunks trying to steal both. And it can be beekeepers that are too rough and clumsy. So our worker bee is now middle-aged at 2 months or so, ready to start foraging for the final phase of her life. But we've run out of time for now, so join me for the next episode of The Hum of the Hive when we'll talk in depth about life as a field bee. Thanks again for listening.
This ends the first half of the Hum of the Hive retrospective. But wait, there's more. For more on this topic, look on your favorite podcast platform.
That concludes another episode of Nature Calls, Conversations from the Hudson Valley. We would like to thank Sandra Powers and Devin Connolly from Cornell Cooperative Extension of Columbia and Greene Counties for production support. And a special thank you to our listeners for joining us on this episode of Nature Calls, Conversations from the Hudson Valley. You can find links to any of the topics mentioned in this episode at our website at ccecolumbiagreen.org. Comments and suggestions for future topics may be directed to us at columbiagreenmgb@cornell.edu or on the CCE Master Gardener Volunteers of Columbia and Greene Counties Facebook page. For more information about Cornell Cooperative Extension of Columbia and Greene Counties, visit our website at ccecolumbiagreen.org or visit us in Hudson or in Acre. Cornell Cooperative Extension provides equal programming and employment opportunities